In this video, we're going to discuss angle terminology and measure. In particular, we're going to discuss some basic terminology that involves angles, define angle measurement in both degrees and radians, and sketch angles with given measure, again, both in degrees and radians.
For the purposes of this class, an angle will consist of two rays which have the same endpoint. The two rays will be called the sides of the angle, and this common endpoint will be called the vertex of the angle. The best way to think about an angle in most of the contexts that we're going to be working in is as a rotation from one side of the angle to the other. That first side is going to be called the initial side of the angle, and when we rotate it to the other side, that other side will be called the terminal side. So in our context, angles will have a starting point and an ending point, going from the initial side to the terminal side. With this view of thinking of angles as rotations, we can see that there are two different directions that we can rotate the initial side. We could rotate it counterclockwise or clockwise, and we're going to denote the direction by making the angle either a positive or a negative angle. In particular, if we have a counterclockwise rotation, we're going to consider this a positive angle. So this will be an angle that is represented by a positive measure. On the other hand, if we have clockwise rotation for our angle, we're going to consider this to be a negative angle, and therefore the measure for a clockwise rotation will be negative. Here are depictions of a positive and a negative angle. Note that the positive angle on the left side has an initial side which is horizontal and is rotated counterclockwise to get to the terminal side. The rotation is indicated by the arc mark with an arrow pointing the direction near the vertex. On the other hand, the negative angle has an initial side that is the one pointing somewhat upward, and that initial side is rotated clockwise to hit the terminal side of that angle. And that rotation is indicated as well by the arrow. In this case, the arrow is pointing in the clockwise direction. In order to compare angles, we need them to be oriented in a compatible way. In order to sort of standardize this, we're going to say that an angle is in standard position if its vertex is located at the origin in the xy plane, and its initial side is extended along the positive x-axis. So for an example, here we have the xy plane, and an angle in standard position would have a vertex there at the origin, its initial side along the x-axis, and then its terminal side somewhere else. So this angle here would be in standard position. Note, however, that it's not clear whether this is a positive angle or a negative angle at this point. We could draw an arrow like this to indicate that this is a positive angle, or we could draw an arrow like this to indicate that it is a negative arrow. Right? So we want to make sure that when we draw an angle in standard position, if the direction, whether it's positive or negative, makes a difference, we should clearly indicate that. While not always necessary, we will typically look at angles only in standard position, and that will allow us to compare angles to each other, or to always have sort of a common frame in which to view angles. In order to use angles in any kind of context, we're going to need a way to measure them. So by the measure of an angle, we mean the amount of rotation from the initial side to the terminal side. Note that the measure of a positive angle will be a positive number because we're rotating a positive angle in the counterclockwise direction, and we're defining that direction to be positive. And the measure of a negative angle will be a negative number, as a negative angle is being rotated clockwise, and we're defining the measure of a clockwise rotating angle to be negative. Like most measurements, there are different units used to measure angles. The two most common ones, and the ones that we're going to see and look at more in depth, are degrees and radians. We'll first discuss the degree measure of an angle. Degrees are the units that most people are most comfortable with. In this case, degrees are easy to define we start by defining one complete rotation to be 360 degrees. So here we see an angle in standard position. The initial side and the terminal side are the same side because we have one complete rotation. So this angle was rotated completely around in a counterclockwise direction, and this would be 360 degrees. All other angles are defined as proportions of this angle. For example, if we only rotate halfway around, we take half of 360 degrees, which would be 180 degrees. And if we only rotate 1/4 of the way around, then we would rotate 1/4 of 360 degrees, or 90 degrees. Here at the bottom of the screen are some common angles in degrees that you're likely familiar with. All of these are defined in terms of proportions of 360. The 270-degree angle on the left, for example, we can see is 3/4 of a complete rotation, and therefore 3/4 of 360 degrees, which is 270 degrees. All angles in degrees are measured as fractions of 360 degrees. In this example, we'd like to sketch angles of 30 degrees and -135 degrees, both in standard position. Since degrees are all measured as fractions of 360 degrees, we simply need to determine what fraction each of these measures are of 360 degrees, and then sketch an angle that is the same fraction of a complete rotation. So for example, with 30 degrees, we want to identify the fraction 30 degrees over 360 degrees, and we can simplify this, and this becomes 1/12. And this means that a 30-degree angle is going to be 1/12 of the way around a complete rotation. Of course, the 90-degree angle that points directly up would be 1/4, and 1/12 is 1/3 of 1/4. And so a 30-degree angle will be something like this, about 1/3 of the way around to the 90-degree angle mark, or 1/12 of the way around for a complete rotation. And so this blue angle here will be 30 degrees. For a -135-degree angle, we approach it the same way. We do note right away that this is a negative angle and therefore will be a clockwise rotation. 135 over 360 simplifies as 3/8. So this fraction will be -3/8. And so we want to rotate 3/8 of the way around, but in the clockwise direction. And so 3/8 would be a rotation right here. And so this angle here, indicated in red, will be a -135-degree angle. Again, notice that the negative part of the angle is what indicates that it is a clockwise rotation, as opposed to a 30-degree angle, which is a positive angle, is a counterclockwise rotation. The second unit for measuring an angle is a radian. Unlike degrees, which are defined by defining the full rotation as a certain number of degrees, and then looking at all other angles as fractional parts of that complete rotation, a radian is defined in a very different way. Specifically, it's defined in terms of the arc length in a circle. To define radians, we're going to start with a circle of radius 1 centered at the vertex of the angle, as we see here. In this picture, the blue side is our initial side of the angle, and the red side is the terminal side of the angle. Both of the sides from the vertex to the circle have a length of 1 because the circle has radius 1. The radian measure of this angle is going to be defined as the length of the arc that subtends the angle. So in this particular case, we have this arc right here, indicated in green, that spans from the initial side to the terminal side. And this will have length r. And so this particular angle will have a radian measure of r radians. We note that it is important that this circle have a radius of 1 in order for this definition of radian to be true. If the circle being used has a different radius, then this definition has to be modified some. However, if we start with a circle of radius 1, The radian measure of the angle is simply the length of that arc that subtends our angle. Notice that our positive and negative conventions will also hold here. In this case, this is a positive angle because the initial side is rotated in the counterclockwise direction to get the terminal side, and therefore this would be a positive radian measure. If, however, we rotated the initial side clockwise to get the terminal side, we would look at the arc length, which would be a positive number, but the actual radian measure would be negative. Now that we know how to define the radian measure of an angle, we can use that definition to find the measure of some common angles in radians. For example, let's say that we wanted to consider the full rotation. We know this is 360 degrees, but we don't know what this is in radians. However, if we start at that initial side and rotate all the way around to the terminal side, the arc that we obtain that subtends that angle is the entire circle. It's the entire circumference of this circle. And so the radian measure of this angle would be the circumference of the circle of radius 1. And as we recall, the circumference of a circle is 2 pi times the radius of that circle. In this case, that radius is 1. And so we obtain a circumference of 2 pi units. And this is the radian measure of this angle. So a complete rotation is 2 pi radians in measure. So here are the 4 other basic angles that we looked at before, representing 0 degrees, 90 degrees, 180 degrees, and 270 degrees. And here we're going to look at what their measures would be in radians. In each case, we're going to use the fact that a complete rotation is 2 pi radians. To get started, the angle with the same initial and terminal side and no rotation will, of course, be a 0 radian angle, just like it is a 0 degree angle. There's no rotation of any kind, and so any kind of measure should measure that as 0. For the second angle, this is a 90 degree rotation. Notice that this 90 degree angle is 1/4 of the way around for a complete rotation. And so its radian measure will be 1/4 of a complete rotation in radians, which is 2 pi. And 1/4 of 2 pi is pi over 2, or 1/2 pi. And so this angle here will be measured in radians as pi over 2 radians. The third angle here is a half rotation. And so we would compute half of the circumference of our circle, so half of 2 pi, and that is equal to simply pi. And so a 180 degree angle is measured in pi radians when in radians. And the fourth angle here is 3/4 of a complete rotation, and so its radian measure will be 3/4 of 2 pi, which will be 3 pi over 2, or 3/2 pi. And so a 270 degree angle will be measured at 3 pi over 2 radians. It is useful to have these 4 radian measures memorized because they do come up frequently, and we can use them to figure out the location of other angles when given their radian measures. Also notice that here we do not use any units when indicating an angle given in radians. If we wanted to indicate an angle in degrees, like for example the third angle being 180 degrees, we would use a degree symbol to indicate that the 180 is representing that measure in degrees. However, when we use radians, we often do not write any kind of unit. If we were to use a unit, we would use radians, which is often abbreviated RAD, but otherwise it is very customary to just leave off units and refer to the radian measure as a number alone. In this example, we want to find the radian measure of 1/3 of a full rotation. So if we start by graphing this angle, we know if we put it in standard position with its initial side on the positive x-axis, 1/3 of a rotation will be somewhere around here. And so this is the angle that we're looking at measuring in radians. Notice that it is going to be between pi over 2 and pi radians, because pi over 2 radians is the angle that points directly up, and pi radians will be the angle that points directly to the left. So these are an upper bound, a lower bound and an upper bound for our desired angle. In order to determine the actual radian measure, we're going to remember that the full rotation is 2 pi radians, and we're going to consider 1/3 of that. So we're going to take 1/3 of a full rotation, which is 2 pi, and of course this is 2 pi over 3. And so this would be our radian measure for 1/3 of a full rotation. So this angle shown here on the right is 2 pi over 3 radians.